Okay, this took me 10 years, 12 days, and 13 hours, and 4 minutes to find you. Oh, and 30 seconds to find for you. This is the ring. Notice the ring, the metal. You can see the outer ring and the inner ring. That's that little bit of metal, that interface ring. Alright, keep track of that. Let's go to... Bear with me with this one. I've got a surprise in the background. I might have to go back up. Okay, here it is again, metal. And then there's this shiny... Let's see if we can zoom that one in. It's with the carbon fiber. You see the carbon fiber and then that shiny metal. Okay, I'm going to sneeze in a minute, sorry. Okay, I had to clear my cribiform plate. That's what sneezing does. Alright, so here's the back of it. Alright, let's get this back over here. Come on, baby. Show daddy, show daddy. Show daddy. Okay, can't quite tell here. We're going to give a pass on that one. Nope. It's the P room, private room. I won't release this for many days, if at all. We have the sub after they did one of the iterations. Right here, look at that little line. See, here's the carbon fiber, but then look at that little line. It means nothing. Remember I told you, I said I remember them overlapping that ring with carbon fiber. Remember I said that? Look at that little line. You're like, man, you're seeing things. That crack you're doing, man, it's just getting too much. That little line. I just like having fun. I'll tease myself. There's that little line, and looking, lo and behold, you observe that they did cover the interface. I'm trying to zoom it in. Oh, different image. Hold on. Shit. Yeah, little line. Let's run with that. Little line, where are you? So little line would be up here. Little line, and there's in the background right here. See it? But I have a better zoomed in shot for you. But you can see they added a strip. A strip of... I don't know, rhino liner? You tell me. La la la, la la la. Strip of, and that's the front ring. So that front ring would have had to go bye-bye also. There it is. There's the one in the back. So there it is right there. There's the strip. Oh, this is that image, one of the images the hyena took from me. You can't tell it in here because of the way they did their photograph. But there's a little strip going above, and that would be right there. La la la, la la la, la 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 la. Come on, baby. Oh, this thing looks like it's got a hole in it right here. There's the ring. So that ring that ripped off, that would have that little strippy strip over top of it. It goes off and on. They found this is after testing without the rear of the hull, obviously, without the rear attached. There's the interface fit for the leg removal system right here. See how thin it is here and then thick on this side. Well, I believe that's interface fit. And I talked about shear pin with my man Zachary. Zachary, look at that little teeny hole, man. Look at that little teeny hole. Maybe, you know, as the legs jack. Yeah, I gotta say it that way. Sorry. As the legs jack off, that it has to shear that pin. I could say it differently. As the legs are pushed away from the submarine via this jacking system, it shears the pin with the steel here. And it's much easier to say as the legs get jacked off, that happens. This is probably just reinforcement right here, this extra piece. So this is like multiple pieces done here. This is interesting. Zachary's mechanical man, mechanical engineer. He loves this stuff. Zachary, tell me if I got to delete that from the part of the video. I will. Zachary. Down the bottom here we have a ding, a dent, a bend. So this appears to be our impact leg, and then it folded, crimped, and also broke 2 bolts, maybe 1 and 2. This was behind here, was in this place, and it rotated it. That's the gusset with the gusset plate with the flat steel and 1, 2, 3, 4 sides. You probably have a better technical way to. Oh, there we go. 1, 2, 3, 4. This one looks like it's. Oh, there again. I'm on a crack again. It looks like it's okay to me. It doesn't look like it's that way. Now everybody says, "Oh, it lost a leg. Lost a leg. Lost a leg." Well, this is part of that shape there, and there is this leg shape here sticking up towards us, I believe, that we're looking down the hollow end of it. It got mangled a bit. I mean, that's not the shape that they would have used. It's not the shape they would have used. It would be, because this would be manually made by smashing it with a hammer if this is the shape. I mean, this is not shaped. So this is an interesting story right here, Zachary. Let me move the mouse out of the way. We know this is the bracket, right? So this is whatever's next to it is the upright. Looking at the upright, I would say it's this, except for this doesn't go. It's sort of like it's one piece. See how the gap might be? Like this is solid, and then they went around and here, and then shaped it here, like here. And I guess the interface would be the tension of opening it up. This shape here as you jam it in, and then you pin it. What the hell? Can't be that simple, huh, Zachary? Look at that. I'm on crack again, aren't I? My crack, is that one of the pins? A pin sticking out right here. That's what happens when you mess around with this stuff like this. So in the rear, we have that. The front, it's double gusseted, and the rear is like double gusseted, but it's kind of a different gusset, isn't it? See how it's shaped like that? That's the bottom leg, but that doesn't look like that there. That'd be up here, I believe, and well, we would still need to see more from the underside. And I think we do, right down to the bottom here. I think you see it there. This is CF carbon fiber, and maybe not. Maybe that's a fracture. Maybe that's what doing it. Remember I said that if it got stuck, Zachary, that maybe when we were jacking it, that the legs folded in, that the carbon fiber was not rigid enough to take the to do it without folding in, creating more interference fit and creating more pressure to pull the leg, to jack the legs off. This looks like steel here, and they changed the carbon fiber. So as you press down, they would fold in and sort of interfere with the interference fit. This is a different version of their one of the iterations. And again, this is one where they go down testing without the computer system, etc., and just testing for whatever reason. There's that blue strap that they connect to. All right, these are my burst images, I call them. They're just sourced images. I have a lot more burst images. And I move that over there. All right, there's the thin interface ring. As you can see, this is practically what, 2 fingers, 2 fingers there, and a thumb put together. So you can see it's very small. It's 1.5 inches. It's smaller than my penis. Wait a minute, it's bigger than my penis. It's 1.5 inches. So I mean, it's huge. It's huge, that thing. So we already went over those. So back here's that little bit of the right back in by my mouse up here, that they thought that they had to add one more touch of this product, but with such a thin overlap. I mean, really, that's it. So you can see where water would want to penetrate behind that. That's it. That's your whole piece of tape. And this is probably, I looked up the company. It can be a combo of pneumatics and hydraulics. Pneumatics can force the hydraulics in here. That could be part of the original jacking system, but they changed it because of ultimately, I think you keep jacking and you might break the line and never get to continue getting what you need done. It still looks like it's on a down slope. If you ask me, if this is 90 and the photographs is there, that looks straight. That just looks like on a down slope. Looks like a lot of stress. Oh, Zachary, I was talking about the, yeah, I got to do a model for it, but let me see if I can do here, Zachary, about what I meant about triple shear and all this other crap. They've got 3 bolts in there up top, right? Currently, 3 bolts. So let's do our 3 bolts. So 1, 2, and 3, and maybe they're not. Maybe they're all just perfect holes, right? Perfect alignment. In other words, 1 half-inch hole, half-inch hole, half-inch hole, and probably 3/8 the way this looks. So 3/8, 3/8, 3/8. But they use a half-inch hole to do a 3/8. That gives you a little bit of slop in it, each side. This has the effect of wanting to pull that direction, right? So let me do our box now, and so let's change. Well, I got to touch and then change colors to yellow. Ah, shit. Ran out of mouse room. But it works for me. No, it doesn't. Yeah, I think I will do this. So as this pushes this way, the internal pipe. Okay, can I do the internal pipe? Oh, hell yeah. All right, let's see if it gets me to do that. Good. We'll take that. We'll change the color of that one to... I don't know how to do this. Let's try this. Okay, yeah, gray. Okay, so as we're pulling that way, Zachary, we have a stress on this side of the bullet connection. I'm going to slide it up. It's pulling that way. So right there, the shear side's on this side. Same as here. Same as here. But because the bolt goes through, Zachary, we have here also, I believe. Alright, we also have it on the underside. So there's the double. There's 2 of them, right? 2 of one piece of steel trying to shear this metal, trying to shear the stationary steel, the bolt. And it's doing the same thing down the bottom. Let's scroll down here. I came with another direction, didn't I? So it's doing the same thing down here. And on this side of it. So it's trying to shear it on each one. And that's what it was. As the water relaxes, as it gets in the water and relaxes, it all of a sudden goes this direction. Maybe it goes that direction. So now all of a sudden the shear is on more on that side. So over many cycles, that bolt, back and forth, it starts with a little bit of play in it. It starts to work on the bolts 1, 2, and 3, only 3, and so we start working on our shearing of that. And then all of a sudden, when he does the panic, time to get the hell out of Dodge, it takes an inclination like that maybe, and it's like, oh, we can finish this off. All the loading is to the rear, and the weight of it just shears it. And we don't know what the bolts are made of. Let me get rid of this. We don't know what the bait wall, don't save, are made of. But I wanted to find the other image where I state that the carbon fiber. See, you can't see it here. There's the connection. And right here, we don't see that carbon fiber. We see this, some metal. And I don't know what the hell that is now. It's right here. So I look up the image behind it, That would be on the other side. I know it's carbon fiber to touch a metal where the weld is, but I don't know what the hell this is now. Piece of plastic. They screw into it. They screw into it. How the hell do they mount it? Does it come down here and mounts here? Does it have that bar and then somehow they just bend some metal up and screw again? And that is that when they bring up that part of the shroud, there's the hole for the shackle. Shackles on my feet won't allow me to dance. Shackles on my feet, listen, won't allow them to bring it up. That thing had shackles. Remember, shackles. It had a rope. It had a sling line connected to it. It liked taking down the sling line. We have not seen that sling line come up. Wouldn't that be interesting to see if it broke? Or did it hold the pieces together? Well, it couldn't have. It was 900 feet apart. But now, Zachary, we got to add in before it broke, before the rope broke, it extended. Then it took its tension, whatever this rope can take. At 21,000 pounds, it's got to be able to pull. Then it had to break the rope. Oh, shit. And that could change the trajectory, too. It could swing around like you're dangling balls, if you will, for just a moment while it holds the stresses and then elastically releases. Elastically, is that right? Kinetically releases the forces from the rope as it's trying to push away. And when that releases, that gives even more force. Oh, shit. Not something else. Zachary, what do you think of that? Ah, fuck, man. Every time I turn around, I get punched in the face with some other new data. See, the rope is right here. And that rope is what they can lift this whole 21,000 pound device with. So that rope has got some serious rating on it. We do not know what the rating is. All right. There's a closer shot of it. And, okay, let's get out of that. Let's get out of that. And let's just take another shot of this, and I'll just zoom it in, since I can't find it. Really? Come on. Private room. Hey, I'm going down to Conowingo Dam. It's in Maryland today. And, oh yeah, that looks like the door opener. And it, incidentally, it has a little different than I originally thought how it works. I thought there was a pin that dropped into here when it closed the door. No. There's a pin that drops in there and a pin that drops in there. And this pushes the door open. And it looks like pneumatic, hydraulics, whatever it might be. And that's the way that works. And here it is here. Okay. And maybe that's how they take it off. This little hole in the back. But I'm bringing your attention to our beautiful extra lapping. And this was already tested, I believe, or going to be tested. So this might be just a carbon fiber. Hold on. And down here you see the shitty line here. This shitty line. And it wraps over that end also. So we got two ends that they decided need to be waterproof, but they use this piece of tape. So we can use water coming from this way with the bending on the bond of carbon fiber, depending on the bond of the whatever this material is to itself, whatever they put over top of here. Was this after testing? Let me look at the thing. We normally build high. It's the people writing this. High-end performance composite aircraft structures, but OceanGate offered us this fun challenge. So we said, heck yes. What you see is a carbon fiber submarine. It goes to a testing site. Next. Let's hope she holds 6,000 psi. So this is it beforehand with the wrinkles in it. with the wrinkles in it, and it says it goes to a testing site next. And it looks like it's on a flatbed, chained down with the legs of all things. So, you know, of course that can create torque and everything else, and twisting. As a couple people got upset with me. Do you notice the twisting there? I'm like, dude, they travel this thing around the country. They strapped it down. You could get all types of bending in that frame with slamming on brakes, things, emergency slamming on brakes, things like that. So note that that the eyeball is ready to go right here. Oh, you can't see it. Sorry. Right here with my mouse. Note that the lens is ready to be installed, so they will be testing this with the lens. So really, that lens is going to be a tough one to shoot down. They didn't test it without the lens. That's something I considered, and you know, they did not test it without the lens, as per this thing saying it's going to be testing next. So now we got wrinkles. This would probably be from the shrink wrapping. And did they shrink wrap this fucker with rhino liner on it? Something's weird about this, because this does not look like carbon fiber been shrink wrapped now at all. So what is this? What is this material? It's over top of here now. What is it? I don't know. But Zachary, I want you to think about that line now, that sling line they use to lift it up. You figure it would be what? I'm trying to remember. Is it a 1/4 on sling lines that you can only use them at 1/4 of their strength? Or is it 1/10 even? I gotta look it up. I forget right now. You only use, because guys, sling lines, unlike chains, you use at a much smaller percentage of their strength to when you're going for rating. So if you had to lift, if you figure this is going to be 10,000 pounds, shit, let me just see. Sling line, maximum use rating. Hold on. Let's see what we got here. So in the background it states guidance ropes. Let's move it over. Shit. Basket hitches, 4 leg bridge. It's a bridle they use it under. Let's see, temperatures 400 degrees. What is the rated capacity? Is, come on, give me the maximum load in tons. Yeah, see the angle changes. See how you lose a lot with the angle, and they were close to 45s, like this, depending on how high they were and the length of it. I'll have to find it and you guys can find it and put it in the comments. I'm getting pissed off, and I've got somewhere to be. Shit, I want to find it for you. Wait, working load. Okay. Come on, baby. Tell me I'm working load. Get it over with. Those chains. Let's see if I remember right. Chains have a different rate loading, and I'm also using that under transportation. Proof test. Braking strength. Oh, that's what it was. Yeah, it depends on how the degree and angle and everything else, it changes. So yeah, I can't disregard that. All right, take care, guys. Remember this part here. I gotta run. I just want to give you something this morning to enjoy in the private room. Love you guys. Ciao, ciao.